Hi everyone. We will see unit number 17, regression analysis. So here we will see in this unit, we will see the objective of this unit and the introduction, the concept of regression, and what do you mean by regression analysis, that we will see in detail, and regression coefficients. What do you mean by regression coefficients? How we are going to compute that regression coefficient, that we will see, and we will see that difference between, already we have seen what do you mean by correlation. Now we are seeing what do you mean by regression. So therefore, in this unit, we are going to see the difference between the correlation and regression, and we sum up the next one, 17.6. We are sum up the unit here and the keywords used in this unit and the terminal questions as usual we will see. So here, what is the objective of our unit? So in this, in a business, several times it becomes necessary to have some focus so that the management can take the decision regarding the product or a particular course of action. So in order to make the forecast, one has to ascertain some relationship between two or more variables relevant to particular situation. So here. Some For example, a company is interested to know how far the demand for television sets will increase in the next 5 years. So keeping in the mind the growth of population in a certain town, here it clearly assumes that the increase in population will lead to an increase the demand of televisions also. So this to determine the nature and extent of the relationship between these two variables becomes the important for the company. So in this introduction we have, um, that means how we are going to find that. So here, in 1889, Sir Francis Galton, and a cousin of Charles Darwin, published a paper on hereditary natural inheritance. So he reported his discovery of sizes of seeds or sweet of plants and appeared to revert or regress to mean size of successive generation. So here, regression. So here, what do you mean by regression? The basic definition we have. So regression is nothing but it is a nothing but it is a statistical method with the help of which we can estimate unknown values of one variable from the known value. From the known values of one variable. Okay. So provided we can say that these two variables are correlated to each other. Okay, so here, if the two variables are correlated to each other, and if one variable, that is, well, I'm considering, if I consider the any two variables x and y, and I will consider that these two variables are correlated to each other, and the values of x is known to me, and the values of y is unknown to me. So here we are going to find out the unknown value of y from the known value. So this technique, what is the statistical method I'm going to use to find out the unknown value, is known as regression. Okay, so for example, if we know that the values of two variables I will consider as one is income, another one is expenditure, and these two are correlated to each other. So then we can estimate the value of the expenditure for a given income, and we can estimate the income for a given value of the expenditure with the help of regression. So here, we are going to find out, or we are going to form the regression equations. Otherwise, that is, we can say that regression lines and regression equations. So here, we are considering any two variables x and y. So we have the two regression lines One is one regression line of x on y, which gives the most probable values of x for given values of y, and another regression line of y on x, which gives the most probable values of y for given values of x. Thus, in the case of two variables x and y, we have we have two regression lines, one to estimate x on y and another estimate to given y on x. So the two regression lines coincide when there is a perfect positive or perfect negative correlation between two variables. So I can so if zero correlation, if the variables are correlation is zero, then what will happen? So see, obviously the two lines of the regression lines are perpendicular. So these regression lines are expressed algebraically as regression equations. So these two equations, one is x on y and another one is regression equation of y on x. So these are the two equations we are going to calculate or we are going to form. So regression analysis we have uh, so it is nothing but the regression analysis. Once again, we can say it is a statistical tool to determine the probable change in one variable for the given amount of change in the order. And this means the value of the unknown variable can be estimated from the known value of the other variable. So the degree to which the variables are correlated to which another respond of the regression depends on the regression line. The regression line is a single line that best fits for the data. That is, all the points plotted are connected by a line in the manner that the distance from the line to points is the smallest one. The regression also tells about the relationship between two or more variables. Then, what is the difference between regression and correlation? So here we have the two differences. So correlation coefficient measures the degree of relationship between the two variables x and y, whereas that regression analysis, study the nature of relationship between the variables. So the correlation coefficient doesn't clearly indicate the cause effect relationship between the variables. That is, it cannot say okay, that is with the certainty when variable is the cause, the other is the effect. So, but whereas in regression analysis clearly indicates the cause and the effect relationship between the variables. The relation, that is the regression analysis, is widely used in all scientific disciplines. In economics, it plays a significant role in measuring or estimating that relationship among the economic variables. For example, two variables, price, demand, or closely related to each other. So we can find out probable value of x from value of y. Similarly, probable value of y can be found out from the given value of x. So the regression line is the line that best fits that data, such that overall distance from the line to the points plotted on a graph is the smallest. So in other words, the line is used to minimize the square deviations or predictions is called as regression lines. There are many numbers of regression lines as variables. Suppose we take two variables, say x on y. Then there will be two regression lines of y on x. This gives most probable values of y given on x. So the algebraic expression of that regression line is called as regression equations. So here we have talked about this one. So how already we have seen the correlation coefficient is whether it is highest degree of correlation, whether it is perfect positive or perfect negative. So we are going to classify if the correlation is in that case means what will happen to that regression. Just we are going to do that. So the correlation between that variable depend on the distance between the two regression lines. Uh, the correlation is said to be either perfect positive or perfect negative. when the two regression lines coincide. That is, only one line exists. In the case the variables are independent, then the correlation will be zero. And the lines of regression will be the right angles, that is parallel to x-axis and y-axis. Um, so here we have the regression lines cut each other at the point of average x and y. This means from the point where the line intersects each other, perpendicular is drawn at the x-axis. So we will get the mean value of x. And similarly, the horizontal line is drawn on y-axis. We will get the mean value of y. So here already we have seen the correlation coefficient. So here we are going to see the regression coefficient. So the correlation coefficient is the geometric mean between the regression coefficients. So R is equal to Bxy, square root of Bxy into Byx. If one of the regression coefficient is greater than the unity, then the other must be less than the unity. So the regression coefficients are independent of the charge change of origin, but not in the scale. So here we will see x on y, regression equations of x on y. So it is given by x minus x bar equal to bxy into y minus y bar. So bxy is known as regression coefficient of x and y, and it is given by r into sigma x divided by sigma y. So here the deviations can be taken actual means. So bxy is equal to, how we are going to calculate the regression coefficients bxy when xy are given to us. So summation xy by summation y square. This x can be calculated as x minus x bar and y can be calculated by y minus y bar. So the deviations are taken from the assumed means bxy. So this can be taken. The formula already we have seen from the correlation coefficient. So likewise here also we have Bxy is deviations are taken for assumed mean, and when the deviations are not taken means this is the formula for calculating the regression coefficient Bxy. Suppose so here the next one is regression equation of y on x. So y on x is given by y minus y bar equal to byx into x minus x bar. So byx is known as regression equation of y on x, and it is given by byx equal to r into sigma y by sigma x. So correlation coefficient is known to us, and standard deviations of the x and y value variables are known to us, means we can calculate byx by making use of this formula. Suppose if the deviations are taken from the actual means byx can be calculated by this formula, that is summation xy divided by summation x square. So x can be calculated by x minus x bar and y can be calculated by y minus y bar. So for the assumed mean, that is when deviations are taken from assumed means byx can be given by this formula. So n into summation dx dy minus summation dx dy, and n divided by n into summation dx square minus summation dx the whole square. So these are the dx is nothing but x minus the assumed mean a, dy is nothing but y minus b assumed b. So here byx is given by n into summation xy minus summation x into summation y divided by n into summation x square minus summation x the whole square. So these are the regression equation standard form with the corresponding how we are finding bxy from the actual mean or from the deviation mean. We have the formulas we have seen. So the next one is the difference between the correlation and regressions. We have uh, so in correlation, correlation is the study of a relationship between the two or more variables, but regression is nothing but the nature of the relationship between the two variables. Whereas in there is in correlation between two variables, cannot say that one variable is the cause and another is the effect. So it doesn't imply the caution. So this, whereas in regression, it is based on one dependent on another independent variables. So it is possible to study the cause and effect. So the presence of association doesn't imply causation. So here in that correlation, the next point we have key measure of the correlation coefficient. So key measure is the regression coefficient. So here usually correlation coefficient lies between -1 to +1. So the value of the regression coefficients are not certain. But if one regression coefficient is greater than 1, then other must be less than 1. So likewise we may have. Okay. So correlation coefficient is independent of the change of scale and origin, whereas regression coefficients are independent of the change of origin but not scale. So these are the example. Let us see under the regression equations. So here the data given, that is x and y data are given to you. We are going to calculate the regression coefficients equations for this. So here we have formed the table xy. So x is equal to x minus x bar and x square column, y minus y bar and y square and xy we have. So x bar is summation x by n and y bar is summation y by n. So x bar y bar we have calculated. By making use of this x bar y bar, we have formed that column. Okay. So the regression equation of x and y is given by x minus x bar equal to bxy into y minus y bar. So we have formed that equation, regression equation of x and y. So apply, that is y minus y bar equal to b by x into x minus x bar. So now we know what is x bar, what is y bar, and just now we have calculated what is byx. So if all the values are known to, that is if all the three values are known to us, then apply on the equation. So on simplifying that equations, we have y is equal to minus 0.65x plus 11.9. So this is the regression equation of y on x, and we have calculated regression equation of x on y. So this is the format we have. So the next example, two lines of regression, that is two lines of regressions are given with the variance, that is 8x minus 10y plus 66 equal to 0 and 40x minus 18y minus 214 equal to 0. The variance of x is given, and find the value of the mean value of x and y and the correlation coefficient between x and y. So that we have how we are going to find the solution, you see. So we considered that two equations. So the two equations, 8x minus 10y equal to 66 and minus 66 and 40x minus 18y, so that is equal to 214. So we have considered that two equations. Um, when we solve these two equations, we are getting the value as x is equal to 13 and y is equal to 17 we are getting. But it is given that that is the mean value of x is equal to x bar. I am considering that as y is equal to y bar equal to 17 we have considered. Okay. So now we have our aim is to find the mean value of x and the mean value of y. So x bar is 13 and so just we can usual method of solving the equations, we are getting what is the x value and what is the y value. So that will become x bar and mean value of x and x bar and y bar we have. And uh, we we take that consider the equations. First equation, that is 8x minus 10y plus 66 equal to 0. From this we find what is x. X is equal to uh, that is 8x equal to 10y minus 66. Therefore x is equal to, I can bring it to that to the right side. So 8 divided by 8 you may have. So this implies bxy is given by that is 10 by 8, which is equal to 1.25 we have. Similarly, we can have the next equation 40x minus 18y minus 214 equal to 0. So from this we can have y is equal to x term and the constant term. So what is the coefficient of x we have? That will become byx. So that is minus 40 by 18. So that will, the value we can have as 2.22. So these here we can see the comparing, see that both coefficients bxy and byx. So bxy is 1.25 and b, that is both the values are clearly greater than 1. But this is not possible. So our assumption is wrong. So R square should always lies between 0 to 1, but what we are getting, it is greater than 1 we have. So our assumption is wrong only. So this we can have 8x minus 10y plus 66 equal to 0 should be the regression equation of y on x. And 40x minus 18y equal to 214 should be the regression equation of x on y. So consider this equation, and we can have this, from this if you calculate what is y is equal to 0.8x minus plus 6.6. So bxy is 0.8 and bxy is 0.45 we have. So that r is equal to square root of bxy into byx. So it is 0.6. So the third value is bxy equal to r into sigma x divided by sigma y. So sigma y is equal to r into sigma x by bxy. So applying on this values we are applying on this formula, we will get sigma y is equal to 4. So the variance of y is equal to 16 we can have for this question. So in this next example, the following table gives the aptitude test score and productivity indices of 10 workers selected at random. So aptitude score and productivity index we have mm, 60, 62, 65, 70, 72. So the data are given to you and productivity index is given to you. So find the two regression equations and estimate. So the first one, the productivity index of a worker whose test score is 92 and the test score of a worker whose productivity index is 75. So our aim is to find out the two regression equations and estimate. So here we are taking x y column, x square, y square, and xy. So we are forming that all these values we are calculating and compute that summation x, summation y, and as well as summation x is equal to 0 and summation x square is equal to 894. Similarly, we are getting summation y is equal to 0, summation y square value we are computing, and summation xy we are getting as 1044. So after computing these and all, we are moving into that equation of x on y. So x minus x bar equal to bxy into y minus y bar. So bxy is given by r into sigma x by sigma y, which is equal to 0.596. So applying these values on that equations, we have x is equal to minus 0.596 into y plus 26.26. So the estimated value of the test score of the productivity index is, so for that is a y value for productivity index y is equal to 75 means what's the corresponding x we can calculate. So x is equal to, on this equation apply for y is equal to 75. So therefore, we are getting the, on simplification, we are getting that x value. So x is equal to 44.7 plus 26.6. So the value we have 70.96. So we have this value. Similarly, find the correlation, regression and coefficients for the following data. So here x square, y square and xy value we have calculated, or xy is equal to n into summation xy by n summation xy divided by square root n into square root of n into a summation x square minus summation x the whole square into square root of n into a summation y square minus summation y the whole square. So applying this on the formula, we can have this one. Similarly, compute or calculate the correlation coefficient regression lines for the following. So xy values are given to you. So we have calculated what is x square, y square and xy value. So we are finding the summation of these, all these, and then the formula we are using here is rxy is equal to n into summation xy by summation x summation y divided by square root of n into summation x square minus summation x the whole square and square root of n into summation y square minus summation y the whole square. So these are the things we have. So just to apply on that formula, we have this answer as 0.95. So we have it is positively correlated. So these are the things we have. So regression equations, if you apply, if you want to find out, means bxy as well as byx. So x minus x bar equal to bxy into y minus y bar. So we know what is bxy and bxy we have calculated. So applying on this formula, we are computing and simplifying. So x is equal to y term and the constant term. Similarly, regression equation of y on x, we have y is equal to 0.95x plus the constant term. So likewise we have, so here we can see the both regression coefficients are if it is negative, means we can say that both are negative. That is, correlation coefficient is also negative. So this is another example. We have so regression equation of x on y we have calculated. So this is the coefficients of x we can have as bxy. So likewise, the P1 and P2. So that product of the two correlation, that is the two regression coefficient should be, if it is less than 1. So the regression is less than 1. So if you calculate the correlation between x and y, r is equal to square root of b1, b2. So it is 0.6 we have. So both the regression coefficients are positive, and here you see x bar and y bar are the intersection of the two regression lines. So here we are solving that two equations. X y value we have, so mean of x and mean of y we are getting. Already we know that sigma y square divided by sigma x square equal to b1 by b2. So applying on this, we are getting what is sigma y square. So variance is 16 we are getting. So another example we have, obtain the equation, regression equation of y on x from the following data. So x is 3, 5, 6, likewise 8, 9, 11, and our corresponding y value they have given. So xy column, and we are calculating what is u equal to x minus 6. Okay, so 6 is nothing but number of observations we are having 6. So summation u is also we are getting 6. So summation v. So u bar is summation u by n, which is 1, and v bar is summation v by n, which is minus 1.33. So we have calculated the coefficient, that is covariance of u comma v by summation uv by n minus u bar v bar. So 4.997 are uv equal to covariance of u comma v sigma u by sigma x, sigma u by sigma x